aromatic carboxylic acid and benzene sulphonic acid. Now, introduction. Aromatic acids are the compounds containing one or more carboxyl group. Aromatic acids are the compounds containing one or more carboxyl group. Carboxyl group, that is, they contain this COOH group, and this carboxyl group is directly linked to the aromatic nucleus. Carboxyl group is directly linked to the aromatic nucleus, then they are called the aromatic carboxylic acids. For example, now this is the aromatic compound. It is the benzene, and this COOH group is directly linked to this benzene nucleus. So these are called the aromatic carboxylic acids. Now this COOH group is made from two functional groups, that is, one carbonyl group, C double bond O, and one hydroxyl group. When these groups are joined to form a carboxyl group, that is, the C double bond O and this OH. Now this is the carbonyl group. This is hydroxyl group. And when these two groups are joined to one another to form the carboxyl group. Okay. And whenever this carboxyl group is directly linked to the aromatic nucleus, then they are called the aromatic carboxylic acids. Now, these aromatic carboxylic acids are classified two types. Aromatic carboxylic acids are classified two types. That is, classification of aromatic. Classification number one, those in which the COOH group, that is the carboxyl group, directly linked to aromatic nucleus. Aromatic nucleus. This is the one type of classification. For example, this COOH is called the benzoic acid. The another example is orthomethyl benzoic acid. This is benzoic acid. Orthomethyl benzoic acid. The another example is hyaluronic acid. So these are the one type of classification in which CO is directly linked to the aromatic nucleus, And second type of classification is those in which COH group is linked to the side chain, in which the COOH group linked to side chain. For example, the CH2COOH. Now, this aromatic compound is linked to this. This is the side chain, and therefore this COH group is linked to the side chain. Now, this is the CH2 is the side chain, and therefore it is called the 2-phenyl or phenyl acetic acid. This is called the phenyl acetic acid, or it is called 2-phenyl ethanol acid. The another example, CH2, the CH2, COOH, and this COH group is actually linked to this side chain, and therefore it is called the phenyl propionic acid. Or it is also called as 1, 2, 3, 3-phenyl propionic acid. So these are the classification of aromatic carbonic acids. Now, the next part of this topic is synthesis and chemical reactions of aromatic carboxylic acids. Synthesis and chemical reactions of aromatic carboxylic acids. The second part of this topic is synthesis and chemical reactions of acids. Now, first compound is first acid is benzoic acid. The synthesis and chemical reactions of acids. The first compound is the benzoic acid. Now, the synthesis of benzoic acid. Synthesis of benzoic acid. Now, this benzoic acid can be synthesized from phenyl cyanide, or it is called the benzonitrile. Now, when this phenyl cyanide hydrolyzed with water, phenyl cyanide hydrolyzed with water, it gives benzoic acid. The reaction is now this is the phenyl cyanide Now this is hydrolyzed with water. Now this water is hydrolyzed. How is hemocyanin hydrolyzed with water? Now first we have added one water molecule like this. The second water molecule is added like this. So there are the two water molecules are required for the hydrolysis of the same ion to form the benzoic acid. This is C5COOH. Now this is the benzoic acid plus NH3. So this is the first synthesis of benzoic acid. Now second synthesis from toluene. From toluene, or it is also called as methylbenzene. Toluene is also called as methylbenzene. Now when this methylbenzene is oxidized with KMFO or chromic acid, when this toluene is oxidized with, now this is the toluene, oxidized with KMNO4, and there is addition of oxygen atom. It gives benzoic acid. So this CH group is converted into COOH. So how many oxygen are required for this conversion of CH group to COOH group? Now these two oxygen atoms with this carbon atom and two hydrogens are removed. That is the one molecule is removed by one oxygen and from this CH two hydrogen atoms. So there are requirement of three oxygen atoms for this CH to COOH. So this is the formation of benzoic acid. So these are the synthesis of benzoic acid. Now the next part of this acid is reactions. That is the chemical reactions of acid. Chemical reaction of this acid. First chemical reaction is that when acyl halide formation. Acyl halide formation. This is the first chemical reaction. Acyl halide formation. Now when this benzoic acid reacts with phosphorus pentachloride, when this benzoic acid reacts with phosphorus pentachloride, it gives benzyl chloride. Now this OH group is removed by Cl. Only this OH group is removed by Cl. So we get the benzyl chloride. This C double bond O Cl. Now plus. Now this O and H combined with this remaining Cl. So this PO and CCl will gives POCl plus 1H and Cl will gives HCl. So this is the formation of benzoyl chloride from benzoyl acid. Benzoyl acid, and this is the benzoyl chloride. Now the second reaction is reduction reaction. Reduction reaction. When benzoic acid is reduced in the presence of steam, when benzoic acid reduced in the presence of lithium aluminum hydride, benzoic acid this is the benzoic acid reduced in the presence of lithium aluminum hydride. So how many hydrogen atoms are required? It is converted to benzyl alcohol. It is converted to benzyl alcohol. That is COOH group is converted into CH2OH. COOH group is converted to CH2OH. So how many hydrogens are required for this conversion? Here 2 hydrogens are given to this carbon atom and 2 hydrogens are given to this oxygen atom, and there is the formation of this water molecule. So here plus H. So how many hydrogens are required? Then so how many hydrogens are required for conversion of benzoic acid to benzyl alcohol? So 4 hydrogens are required for conversion of benzoic acid to this benzyl alcohol. So this is the second reaction, conversion of benzoic acid to benzyl alcohol. Now third reaction is nitration reaction. Nitration reaction, third reaction. Now when this benzoic acid undergoes usual electrophilic substitution reaction. Benzoic acid undergoes electrophilic substitution reaction. Now this COOH group is a metadiacetyl group. In this benzoic acid, this COOH group is the metadiacetyl group. Therefore, the incoming electrophile, that is NO2 group, is linked at the meta position and to form the meta nitro benzoic acid. So when this benzoic acid is treated with concentrated nitric acid, in the presence of concentrated H2SO4 will use young nitro benzoic acid. So the COOH group is the metadiacetyl group, and therefore this incoming NO2 group is linked at the meta position to form the young nitro benzoic acid. So this is the nitration reaction of benzoic acid, and these are the reactions of benzoic acid. Now the next aromatic carboxylic acid is the anionic acid. We can take part in the